Okay folks, in this lesson we'll be taking a look at the color nodes. Now this is the material that or shader that has been applied to this shader ball. So let me middle click on it and open up its shader network. We have discussed the most important and the most used nodes basically, and from now on we're going to be taking a quick look at some of the other nodes that we have in this list. We have AOV nodes. We will be discussing these nodes in the rendering section when we discuss the AOVs. Then we have the color nodes, which are the subject of this lesson. First of all, we have this color convert node, which basically allows you to convert colors from one color space to another. Next, we have the color correct node. And the color correct node basically allows you to adjust the gamma, hue, saturation, contrast, exposure. You can invert your image. So there are so many options, and this is definitely a very, very useful node that you're going to use it a lot in your workflow. So let's actually do an actual practical example with the color correct node. Let's say we want to create a realistic wood shader. So this is the standard surface shader. Let me add an image. And for this, let's use this wood parquet. Okay. And connect it to the base color of our standard shader. Let me just run the IPR. Now we can increase the base weight to something like 1. And for a shader like wood, you need to increase your IR to something like maybe 2, 2.5 or even 3. So let me go to 2.5. Now for the specular weight, obviously we want to have a black and white version of this image. So here we can use the color correct node. So let me connect the output of our image to the input of the color correct node. And if I connect the color correct node directly to the Arnold Beauty, we can actually see how this looks. Now actually, before doing that, let me increase the scale U and V so we have a bit more repetition. Now for the color correct node, and we're going to be connecting this to the specular weight. So let me first of all zero out the saturation, set the gamma probably to something like 0.7, and right now if I connect this to my specular weight and connect the standard surface to here, I don't want the reflections to be that shiny. So what I want to do, and if I select my color correct node, I can use the exposure value to actually make the overall image a bit darker and therefore decreasing the overall specular weight. Okay. Now for the specular roughness, let me just control drag this color correct node and connect the image node again to the input and connect this one. Let's see what we want to have here. So this is our color correct node that is connected to our specular weight. Now the white parts in this shader are basically more reflective compared to the dark parts, and in the specular roughness we want to make sure that the dark parts of this image are basically rougher compared to the white parts that are shinier and more reflective. But if I connect the same color correct node that we have connected to our specular weight also to our specular roughness, what's going to happen, as you can see, the specular roughness is from 0 to 1. So the darker the value, the shinier the reflections will be. So we actually need to convert this node so the dark parts that are here will become basically brighter and therefore rougher, and the white parts will become darker and therefore shinier if connected to our specular roughness. So if I use something like a ramp float, we can obviously use the color correct node to invert, but I tend to use the ramp floats node because it gives me a bit more control. So we can connect this to our input of our ramp float, and now connect the ramp float directly to the specular roughness, and also let me connect that to here. Now before connecting this, we can probably adjust the color correct node a bit. Let me just add a bit more contrast, and the exposure probably something like 0 or even 0.2. Okay, now using the ramp float node, right now if I connect this to the specular roughness, which is connected, okay, what's gonna happen, we're gonna get this very, very rough shader, because this image is first of all way too bright, and we need to actually invert the image to connect it to the specular roughness based on the image that we had applied to our specular weight. So in this case, let me probably something like that. Let's increase the let's just use 0.3 here. So this is the map that will be connected to our specular weight, and this is the map that will be connected to our specular roughness. You can see we are basically inverting this image, and this way if I connect this, the parts that are having more specular weight using this color correct node are going to be also shinier using this ramp float node that we have connected to our specular roughness. Okay, and now the final thing I want to do is to add some bump. So let's look for a bump 2D node. I'm just going to directly connect this color correct node to the bump map input and connect this to the geometry normal, and use a bump height of probably something like 0.1 or 0.15. Let me just set my scale to something like 120, and this is the actual resolution. So if you set the scale to 100, you are using the exact resolution that you have defined in your output, but the zoom is actually just zooming in and out of the image. And if I use something like 200 in scale, I'm actually doubling the overall resolution again here. So this is, let me just try something like 125 so you can actually see the details here. And as you can see now, we have this very beautiful realistic wood shader. I just want to quickly go through the whole shader again. So if I just come here and actually stop the IPR. First of all, in our standard shader, we increased our IR to 2.5. Then we connected, just open up this window so you can actually see the preview. Okay. Then we connected this image to our base color. We use our color correct node to do some color correction, and we have assigned this image as our specular weight. And now as you can see, specular weight obviously goes from 0 to 1, so the darker parts are gonna be less reflective and the whiter and brighter parts are gonna be more reflective. Now then we have inverted this image and did some color correction on it, and we assigned this image to our specular roughness. So we inverted the image because the specular roughness goes from 0 or black to 1 or white. So the parts of the image that were white in our specular weight needed to be darker because we wanted them to be shinier. So that's why we actually inverted the image using the color correct and the ramp floats node. And finally, we have used the same color correct node to be used as our bump map, and we connect our bump map to the normal input of the standard surface shader. And this was the final result. Okay, now if I just get back to my color nodes, we discussed color jitter in its own specific lesson. We have this composites node, which basically composites two RGBA inputs using a blending mode that you can define in the operation section here. Just connect two images to inputs A and B and play around with different operation modes. And finally, we have this shuffle node here, which combines RGB and alpha inputs to output an RGBA by default. Additionally, there are parameters to shuffle the channels to choose which of the RGBA input channel go to which RGBA output channels, and parameters to negate the colors. This node could be useful, for example, with normal or vector displacement maps that have a different channel convention. Okay folks, in this lesson we learned about the color nodes. See you in the next lesson.